In MaxEnt, we try to maximize entropy, that is, uncertainty, subject to certain constraints that represent what we know or assume from outside of the data. The mathematical tool that we use to do this is called Lagrangian, and here we try to get a geometrical intuition for this process. Let entropy, h of y, be represented by this partial red circle, and let a single constraint be represented by this blue line, where constraints are often written as the expected value of some function of the data set to some constant value, here k. Note that this isn't an accurate representation of this process, but merely an intuitive representation of the process. Entropy is maximized by adjusting entropy until it is adjacent to the constraint or constraints. We can find this as the point at which entropy and the constraint are tangent to one another. This is the point where the gradient of the entropy and the gradient of the constraint are proportional to one another, where proportionality is represented by the lambda in the equation shown. We can rearrange this expression and set it equal to 0, and this is the gradient of the Lagrangian. The Lagrangian itself looks like this, and it packages both the thing we are trying to maximize, here entropy, and all of the constraints.